Now I'm going to load up a demo file for accessing the keys. So I'm going to go and access the files that we downloaded from the GitHub repository. I'm also going to open up my CircuitPy drive here on the right-hand side. So this CircuitPy drive down here corresponds to the files that are actually on my CircuitPython board. I want to make sure that I have all of the libraries installed, so I'm going to look through here into my lib directory on the CircuitPy drive, and I'm going to look into the files I downloaded from the class source code repository, and I'm going to make sure that I've got all of those library files by dragging all of that into the lib directory here. And you'll see it asks me if I want to replace it. I'm going to skip them if it already exists. Okay, so now I've got the libraries on my CircuitPy board matching with what's in the class repository. And I'm going to grab this guy here, the demo NeoKey, and drag it over to the CircuitPy drive. It's going to copy it over. You can see it is appearing here. Now I'm going to flip back over into Visual Studio Code and make sure that I've opened the CircuitPy folder. So now I have all of the list of the files here on the left, and these are the ones that are directly in the CircuitPy drive. And if I open up this demo NeoKey file, I can see that there is some code in here that I want to run. And to actually run that, I need to go over into the code.py file. This is the one that is run right at startup. Maybe I want to put something in here just to make sure that I know that this code is running. And to run this file here, this demo NeoKey file, I would write import demo_NeoKey. And this is going to load that Python file and run it. So now if I hit save, and I've already got my serial monitor open here, I should see that update. I have noticed that sometimes you may need to restart the monitoring if you've unplugged and replugged the board. So if I hit save here, I can see this hello music devices that I wrote. I can also see this error about no pull-up found on SDA or STL. That can indicate that there is not a board attached. I have started to see this sometimes in other situations. So for now, I'm just gonna maybe hit reset to restart the board. I think there may be some kind of startup issue I need to look into. And now you can see that actually we are getting the output here. So if I press these buttons, you can see what's happening is the button is lighting up and I'm getting a message in the serial monitor here. So let's look at how this code works. Okay, so inside our code.py file, we are loading this demo NeoKey file. Then inside this file, we're going to load some of this code from Adafruit that is going to give us this NeoKey object. So from this library, I'm going to import just this one object. We're going to tell the library which I2C bus we want to use. So the I2C bus is the bus that is broken out onto those connectors. And on the I2C bus, there are 4 wires. You can see here there's actually 4 wires that are hooked up to that connector. And we have power, red, we've got ground, black, and we have serial data and serial clock, SDA and SCL. And with these 4 wires and the I2C bus, we're actually able to access any of the devices which are hooked up to that bus. And the way that we access each of those devices, in this case we have the NeoKey board and we have the NeoSlider board, is that each device on the bus has an address. And the NeoKey has a default address of 0x30 in hex. And our Neo slider actually by default would have the same address, unfortunately, the 0x30, but what we did is we went onto the back and we cut one of these jumpers, the address jumpers. We cut address jumper 3, and that changed the address to be 0x38. On my board, I just put a little sticker just to remind myself that I've cut the jumper and changed the address. So we're going to be able to access the Neo keys here on address 0x30, and then in the next version of our code, we'll access the Neo slider at the other address. So just to recap, to access the devices on the I2C bus, we need to actually create an I2C bus in our Python code and tell it which pins to attach to. The board object allows us to access things like figuring out if there's a built-in LED that we could access, or for example, it's going to map this to the I2C pins that are hooked up to this physical connector. Okay, so we've got our I2C bus, which is going to allow us to do operations with the devices that are hooked up onto our Qt I2C connection. Next, we're going to create the NeoKey object. So this NeoKey 1x4 is some code that is provided by Adafruit. And just as a reminder, the way that we got access to those is we downloaded the library, in this case from our source code repository, and then we copied that onto our CircuitPython drive. So here, when I say from Adafruit NeoKey import this object, what that is doing is my CircuitPython board is running that line and is looking for the Adafruit NeoKey module, and it finds that in the lib directory, this one here, right? These are the files that are on our board. And it's going into this directory in this case, this module, and we're loading some code from this Python file. Okay, so we're loading the code that we're going to be able to use to access the functionality of the NeoKeys. Next, we need to tell this code how to actually connect to the physical hardware. So we do that by saying we want to use this I2C bus. So we're saying use the pins and the I2C hardware that is hooked up to this wires. And I want to connect to the NeoKey at address 0x30. So that's going to allow us to connect to this NeoKey. If I had another NeoKey board, I could also hook this up to the exact same I2C bus. I would just need to solder a little jumper on the back to change the address. So by default, this has address 30, and I could change it to address 31 by changing something on the back. And so I could basically have multiple of these same boards hooked up, each one having their own address. Okay, so we now have this NeoKey object, and we've connected it to the physical hardware at address 30 on our I2C bus. Great. So now we get into our main loop, this while true. And the way that Adafruit has implemented this library is for us to be able to check the status of each button. We just access this as if it was an array. So if I say NeoKey 0, that is going to access the status of this button here on the left. If I say NeoKey 1, that's going to be true if this button is held down and false if not, and so on for NeoKey 2 and 3. So 0, 1, 2, 3. So for us to check if the button is being pressed, I just need to check if the value of NeoKey 0 is true or false. In this case, if the value is true, I'm going to print this message, and I'm going to set the pixel at address 0 to red. Otherwise, I am going to set the color of the pixel at 0 to 0, which is off, right? So the same way that we can access the status of the button as a true or false by accessing this array, we have an array of 4 pixels where each pixel also is an array and corresponds to the same button. So to get the status of button 0, I would say NeoKey 0. To write the pixels at 0, I would say NeoKey.pixel0 equals a value, and that's going to allow me to set each color individually. So for the first button, button 0, I'm going to check the status, print button A, set it to red. For the second button, which is at array index 1, similarly I can check the status and set the pixels and so on. And that is pretty much all we need to know about the NeoKeys. So just to recap, what did we need to do? We had to make sure that we have the library for the NeoKey copied over to our CircuitPy board, and it needs to be in the lib folder. You need to make sure that it isn't in a lib/lib/lib/lib directory, but it's just here in the lib folder. We copied over our demo code, this one here, this demo NeoKey. So we copied this from the source code repository via the stuff that we downloaded as a zip file to our board. And we went into the code.py, and we made sure that inside this code.py we are importing this file to load that file and run it. Then inside this code, we imported the software code that's going to allow us to talk to the NeoKey. We did a little bit of setup here where we said we want to attach the NeoKey to this I2C bus, and we want to attach to the NeoKey that has this specific address. And we haven't seen it yet, but if we want to attach more devices, each one just gets a different address. And we need to set the address physically on the hardware and then also in the code. To read the status of a key, we just access it through accessing it as if it was an array. So to get the status of button 0, just read that. And then for each of the buttons, we're also able to use the pixels array to set the color of the pixel of that button. So for example here, if instead of changing the first button to red when it's being pushed, if I wanted to change it to some other color, I could look up RGB color picker, for example. And you can see they even have it, it's so common these days, believe it or not. They even have it built into Google, right? So here I can play around with some different values. Maybe I like this kind of purple, let's say. Very on brand. And you can see here there's this hex value. This is the amount of each of the RGB components, so I could copy that over. Now I could go into my code here, and let's just do this. I could say color purple. Purple equals this, and to convert this from a value for the web to a value for Python, I would add in 0x. What this prefix does is it means that the rest of this is in hex notation. So basically it just means that it's going to interpret these characters as a hex value, which is the same as what we see over here. So if we look over here, and you see how the RGB is changing and the hex value is changing? This hex value is just a way of encoding each of the RGB values into one number. And then on the web, you might be able to use a hashtag to say that this is hex, but then in Python, we need to give it this prefix 0x. So then in here, instead of this hard-coded red, I could change this to color purple. I'm gonna hit save. And we can see our code rebooted. And now when I press the key, I get purple. So the sky is kind of the limit with what we can do once we've got these inputs mapped. And I hope that gets you started on being able to access our first NeoKey board, access our first device over the I2C. And what we'll see in future sections is accessing other devices such as the Neo slider, and then eventually we're going to be able to also access rotary encoder, distance sensor, and all sorts of other things that we can hook up to this I2C bus.